Okay, so we're moving on to more conics. We had circles, and now we're going to deal with ellipses. We're going to write them in standard form of the equation, find the eccentricity, that is the measure of the ovalness of our ellipse, and then we're going to graph the ellipse. Alright, so looking at the conic section, if you take a conic, flip it upside down, you have two of them on top of each other. If you slice perpendicular through it, that's where we get our circle. When you kind of slice at an angle, the middle one, that's where you get an ellipse. And then you have a parabola and a hyperbola, or the other two. Okay, so the definition of ellipse is the set of all points where the sum of the distances between these two foci, so we have two foci, and then any point around the ellipse, those distances from each foci to that point, if we add those together, it will always be the same number. It's a positive constant. We have the major axis, which is always the bigger one. It's major, and it goes from the two endpoints, what you call the vertices of the ellipse. The center is kind of just like where the minor and the major axis, they intersect each other. And then the minor axis is the smaller line segment. It's always perpendicular to the major axis. Okay, so here's a simulation. I'm going to run this, just showing you, so anywhere point around this ellipse. So I can move this around any point, and here we have from the foci to one foci to that point, from the second foci to that point. So we can adjust the size of the minor and major axis, or axes. But anywhere along this point, we can see that here we have the distance of the major axis, and then if I take the distance of the foci of the first one, and then take the distance of the foci of the second one, those add together to equal the distance of the major axis. So no matter where I go, those two, the sum of those distances will always be the same. It will be the length of that major axis. Pretty cool. Okay, so here's another simulation. So here we have our foci B and our foci A, and any point around the circle D. We can see those distances from B to D and A to D. They are always the same. So see how it's A plus B is 6.78. A plus B is the distance, or those two line segments added together. And then if we change the size of the ellipse, then that, no matter what ellipse we have, those distances will always add together to be the same number. Okay, so looking at the standard equation of the ellipse, it is very similar to a circle, right? Except for now, like I did one problem that I tried to change the circle, and then I'm like, oh, we're talking about the ellipse. So the only difference is here we have x squared divided by a squared plus y squared over b squared, where in our circle we didn't have these fractions here. We didn't have an a squared or b squared underneath. But the major thing here on the equation, and there's two different equations, but they're the same thing. They need to be set equal to 1. Okay, so they need to be set equal to 1, where on our circle it didn't matter what they were set equal to. We just couldn't have fractions or numbers in front of the x squared, right? So here's our vertices. Vertices are the endpoints of the major axis, right? So here we have a horizontal ellipse, and our vertices are negative a0, a0, and then our foci is negative c0, c0. And then to find c, we can take our Pythagorean theorem, c squared equals a squared minus b squared. And then here is a more general term, right? This is the most basic, x squared over a squared, where we have x minus h quantity squared plus y minus k quantity squared equals 1, that would be the normal. If I just looked at the top here, oops. If I just looked at the top and set it equal to 1, that would be a circle. But now we have these fractions, right? So h, again, to find our center, we have h. So that means we got to take the opposite of whatever's inside there. And then we also have to, for k, we have to take the opposite of that to find k, opposite of h to find h, or the opposite of the inside to find our h, and opposite of the inside on the y to find our k. So that's how you find the center, kind of the same thing as the circle. Then we'll go farther on this. You can look through these things, but I'll just basically show you how to graph, and we can come back later and do more difficult problems to find your foci and your minor and major axes. They're really not too bad. But I want to show you the second one. So this is for a vertical ellipse. And here, notice the only thing that really changes here is a squared and b squared switch places. That's because it's now vertical. That really doesn't matter too much. I mean, you can do it without it. I think the two equations, when they switch like this, kind of messes up students a lot. So I'll just show you how just I do it, just leaving the a and the b, a squared and b squared the same. Because really, why they switch these is because in a problem, the number underneath the x squared is smaller than the number underneath the y squared. And so whatever number is bigger as a denominator, that just tells you which axis. So it would be y-axis that has the bigger, that is the major axis, because a squared is going to be bigger. On the other one, the one underneath the x is going to be bigger, so that's why the x-axis contains the major axis. Okay, and then the eccentricity, the ovalness of each ellipse, and we find that by its the ratio of our c over our a, and it's always going to be between 0 and 1. So here's an example. We have the equation 25x squared plus 16y squared equals 400, and we want to find the vertices and the foci. So you could pause this and look through it. I'll just talk over it, and then I'll pretty much redo it in kind of a basic way of just kind of how to graph this, right? I won't be too worried about finding the foci, but I will be interested in you finding the vertices, okay? And that's just the endpoints of your major axis. I also want you to find the endpoints of your minor axis, but those aren't called the vertices. Okay, so just looking through this, you know, we have to set it equal to 1. That's the big thing, right? That's where we're going to get these fractions on the x squared and the y squared. So that's why they divide everything by 400. Okay, and then they reduce 25 over 400, 16 over 400 to x squared over 16 plus y squared over 25 equals 1. And one major thing is it's always addition. With ellipses, it's always addition in between the x squared and the y squared, just like circles are always addition too. When we have subtraction, that's when we're talking about a hyperbola. Okay, so then to find your a and b, again, it really doesn't matter. All you have to do is take the denominators and square root them. So we get 5 and 4. Now, to actually find the vertices here, really all you have to do, and the vertices are on the major axis, but you just look at what number of the denominator was bigger, right? 25 is bigger than 16, so look at the numerator. The numerator is y, so that means my major axis is going to be on the y-axis, or it's going to go vertical because y is vertical, x is horizontal. So 25, the square root of 25 was 5. So that means from our center, I'm going to go vertical up 5 and down 5. And then 16, square root of 16 is 4, and it's underneath the x. So that means from the center, not from 0, 0, but from the center, which for this problem, the center is 0, 0. I'm going to go to the right 4 and to the left 4. So really, it doesn't really matter which one's A, which one's B. I think that is just confusing. So then our vertices, since we're going from 0, we go up 5, so that's 0, 5, and then we go down 5, which is 0, negative 5. So that'll be our vertices. And then the major axis length, which I will ask for, that's not 5, it would be 10, right? It's from vertex to vertex, it would be 10. And then the minor one, so these two I will ask for on the pre-quiz and the quiz and the test. I went 4, so just double it, is 8, okay? And you can see the rest of there. To find the foci, which is not concerned on the quiz or the test, but if you go on to math, you should probably know this. But so we just find our C, okay? And we always take the bigger denominator minus the smaller denominator. So C squared equals 5 squared, which is 25. 25 minus 16, right, is 9. And then square root that because we want C. So C is equal to 3. And then we go from our center. We start 0 is our x. And then we're going to take our k, which again is 0. And then we're going to add and subtract our c. And that will find our foci. Now the only difference here is if it was switched, if it was a horizontal ellipse, then it would be on your x-axis, because here our big number is underneath the y, so that's why I did k plus or minus c. So if the bigger number was on the x, then I would do h plus or minus c, comma, it would be your k would be here. But since our k is 0, then it would be 0 here. That's why I put a 0 right here. So in all general, that's going to be your h, which for this problem our h was 0. So that's how you find the foci. So the foci matter, determining the major and minor axis kind of matter which denominator is bigger, and that's going to help you graph. So whatever the square root of the denominator you get, underneath that letter of the numerator, that's the way you're going to go. So if it's a y, you're going to go vertical from your center up and down the square root of the denominator amount. And then if underneath the x, the square root of the denominator, you're going to go left and right from that center. So it's kind of like a circle a little bit. Okay, so here's that same example. So if I gave you this on a quiz or a test, basically what I would ask you to do is find the center. Find the center and major, minor axes. Okay, so that's what I basically ask you for. So again, you would have to set it equal to 0, right? So we would divide everything by 400. So now these are going to reduce to x squared over 16 plus y squared over 25. Now it's equal to 1, so now I can set it up. The general equation is x minus my h quantity squared plus y minus my k quantity squared. Then my x squared minus h quantity, x minus h quantity squared is over a squared. And sometimes in different books they say the change. Remember that from physics or chemistry, the change in x, and this one would be the change in y squared, and it's equal to 1. Right? So so here, since nothing is subtracting from h, nothing's subtracting from y, that's why we get our center here as at 0, 0. Then to find the major axes and the minor axes, I'm just going to take these denominators and I'm going to square root them. 16 and square root 25. So that would be 4 and that would be 5. And then if I just times those by 2, oh, why did I do 8? 8's the answer. So I get 8 and I get 10. The major is just the larger number, so this would be the major. This would be the minor. Okay, then the second thing I'm going to ask you to do is I'm going to ask you to graph. So you'll find the center, the minor, and the major axis, and then I would ask you to graph. So here we do graph our center is 0, 0, 0, 0, and then I would just ask you to, all you have to do is graph. So the hard part of this is saying, okay, which one? I don't go 8 over. 8 over is the full length of the minor axis, right? And 10 would be the full length from vertex to vertex, right? And then from endpoint of the minor, from endpoint of the minor. So only use the square roots number, the square root of the denominator, so 4. And that 16, that denominator was underneath x. So it was underneath x, so that means from my center I'm going to go horizontally, because x is horizontal, over 4, 1, 2, 3, 4, and left 4, 1, 2, 3, 4, and put my endpoints on that minor axis. So you can see all the way across I go 4 and then 4, that'd be a total of 8. So don't go 8 over from the center and 8 over from the center, right? It's only 4 because the whole thing is 8. Now 5, got that from square root 25, and that 25 was underneath the y, and y is vertical. So I'm going to go up 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you can see that the distance from the vertices is a total of 10. Down 5 here, down 5 more, 10. And then draw the best oval that you can. So that's all I ask for you on a quiz or a test. Center, the minor and major axes, and then to graph it. Graphing, you graph from your center, you take the square roots of the denominators, whatever the denominator, whatever letter is in the numerator of that denominator, right, is going to tell you which way to go, either vertical or horizontal with that number. Okay, so here's another example. You can go ahead and pause it, freeze, and you could find the center. You could use the equation for the eccentricity. You can find the vertices, and then you could use your h comma plus or k plus or minus c here, or if it's the other way, then it would be h plus or minus c comma k to find those foci. Alright, to find foci. But really remember, on a test I'm looking for the center, the major, and the minor axes. So if you just want to do those things, that's great. And then to graph it. Okay, so you can pause the video, try it out. Okay, this one's already set equal to 1, so we're good there. So now all we have to do is find the center. Center is always opposite of the number with x, so that'd be 2, because it's a point, right? So it has an x and a y, and then opposite of this number is -1, so there's my center. Now to find the minor is you take the smaller denominator, square root it. 3 times it by 2, we get 6, so the minor is 6. The major, square root the denominator of the bigger denominator. 5 times it by 2 is 10. So the major is 10. Okay, so there would be that, and then you could graph that. Right, so we're over at 2, so over 2, down 1, 2, -1, there's our center. And then here's the tricky part, right? So the larger denominator is underneath the x, so that means I'm going to go with this 5, I'm going to go right 5 and left 5. So from this center point, I'm going to go right 5, 1, 2, 3, 4, 5, so it's down here still, and then left 5, 1, 2, 3, 4, 5, and still down at -1. So there's that major axis. You can go ahead and draw that across if you want. You don't have to. Then we go 9, the smaller denominators underneath the y. So vertically, I'm going to go up 3 and down 3 from that center. So 1, 2, 3, and 1, 2, 3, and that would be the minor. And then you can draw the best oval that you can. So that's all I'd ask you to do on a test or a quiz. For the foci, since this is horizontal, right, the major axis is horizontal, so that means my foci are going to be somewhere around here on that purple line there. So that means that all that's going to be changing, notice on this line my y values would be at -1, so the y values are not going to be changed, right? So I'll be using this one where my y values do not change, because it is a horizontal, larger denominators underneath the x, so that means that I'm only going to change my x value for my foci. So foci is going to be my h plus or minus my c, comma my k. So to find c, well, c squared is equal to my a squared minus b squared, where a squared is just the larger denominator, which is 25, and then minus my smaller denominator, which is b squared, which is 9. So I get, excuse me, 15. And that's not 15. Well, geez. Wow. That's 16. Right? And then so to find c would be the square root of that, so that'd be 4. And it's a distance, so I don't need to do plus or minus, right? So it's 4, positive 4. So that means from my h, which is 2, I'm going to go add 4, comma -1, so that'd be my 1 foci. So I go from 2, I'm just going over 4, 1, 2, 3, 4. Okay? And then I'm going to take 2 and I'm going to subtract 4, -1. So this one would be 6, -1, which I already graphed, 6, -1, and this one would be -2, -1. Or I could just, from the center, I could have went 1, 2, 3, 4. Right? So there would be my foci, usually labeled foci 1, from left to right, foci 1, foci 2, just F1, F2. So that would be your foci. And what else is asked for? Vertices. Vertices you can see right here are the endpoints on the major. So that's 1, 2, 3, -3. I shouldn't put there. -3, -1. And then 2, 3, 4, 5, 6, 7, 7, -1. And you can tell if I take -3, from -3 to 7 would be a distance of 10, and that's what our major was, right? I think that's all. Oh, like eccentricity. So eccentricity, E is equal to your C over your A, where A is your the larger denominator square rooted, and C is 4 that we found. So E is equal to 4 over 4, which is equal to 1. Because my A was 1, correct? No, my A was 5, sorry. Not 1. So it's not 1, it was 5, so 4/5. So 4/5, which is about, so 80%. So it's the ovalness is about 80% or 0.8. Okay, so here we're looking at equation in, so we're looking at general form, right? So here we want to put it in center radius form. That was of a circle. We don't have a center radius, but here we want to put it in standard form for ellipse, right? So again, what we're going to have to do is we're going to have to do, we're going to have to do completing the square twice for our x's and for our y's. So move over the 36 here. Put our x's by each other. Put our y's by each other. And you could have probably left a space here and here for our new C's that we're going to have. But remember, when we do completing a square that our a's have to be 1. So basically what we need to do is we need to factor out the 9 on my x's and factor out the 5 on my y's. Okay. Alright, so factor out a 9, put a 9 on the outside, 4x, and then our plus c is going to go in here, our new c. And here factor out a 5, minus 6y, plus your new c for that one, equals negative 36. Okay. So now we have a new b and a new b here. Then we're going to take 4 divided by 2 and then square it. So we get 4. So we're going to add 4 here. So x squared plus 4x plus 4. Okay. And then on this one, we're going to take our b divided by 2 and square it. So that's negative 3 squared. That's 9. Plus 9 equals... Okay, so over here we had a negative 36, right? But here we have to be really careful because I can't add 4 on this side because I added 4 inside this parentheses. So what I'm really adding here is actually 4 times 9, which is 36, right? Because if I distribute that 9 back in, when I get 36 in here, so really I'm adding 36 to this side. And then on this one, I'm not adding 9 over here. I'm really adding 40, because if I would distribute that 5 to all 3, I'd get 40 here. So I'm really adding a 40. Okay? So that's the really catch on this one when you have to go from this general form to the standard form. Okay? So now we can go ahead and factor our quadratics there. So we get our x plus our b over 2. And our b over 2 was 4 divided by 2, which is 2 quantity squared. And then we just have our 9 in front. Then on this one, we have our b over 2, which was negative 3. So y minus 3 quantity squared. And then our 5 out in front. And equals positive 40, right? Because negative 36 plus 40 is 40. Okay, now we have to set it equal to 1. So that's where we divide everything by 40. Okay, so we get x plus 2 quantity squared. This time it's over 5. And then plus y minus 3 quantity squared over 9. Sorry, not 9. That's not 5. Well, if I would do my math right? As a math teacher, I probably should do my math right. But here, I shouldn't add 40 here. I should add 45, right? Because 5 times 9 is 45. So I should have added 45 there. So this wouldn't be 40. It would be 45. Then this would be 45. This would be 45. 45. And then I would have 5 and 9. Right? That makes more sense. And now it's over 45 over 45, which is now 1. So now it is equal to 1. Now I did my math correct. Now we could find our center, which is negative 2, opposite of what's with x, and then opposite what's y. What's with y was 3. There's our center. Now our major and minor. So our major axis would be the larger denominator square rooted. So 9 square rooted is 3, and then times that by 2. So our major is 6. And then smaller numbers are minor. Square root 5 squared. Square root of 5 is square root 5 times 2 is just 2 root 5. So minor is 2 root 5. Okay, then to graph it, you'd graph your center. Oops, probably shouldn't draw that yet. Erase that. Okay, so we're at negative 2, 1, 2, up 3, 1, 2, 3. There it is, negative 2, 3. And then our major is 6, right? So it's going to be a total of 6 long. So the bigger number is underneath the y. The bigger denominator is underneath the y. So I'm going to go vertical from my center, and I'm going to go up 3. 1, 2, 3. And I'm going to go down 3. So that'd be a total distance of 6, right? There's your major. Now your minor, you're going to have to probably get out a calculator and take 2 square root 5 and round that number. So 2 square root 5 is approximately about 4.5. So we're going to go about 4.5 to the right. Oh no, sorry, not 4.5. Because that would be the length of the minor. I'm not going the minor length, right? I'm only going square root 5. From the center, I'm going to go square root 5 to the right and square root 5 to the left. So that would be approximately 2.2. Approximately 2.2. So I'm going to go 2, 1, 2, and a little bit more. Then I'm going to go 2 to the left, 1, 2, and a little bit more. So there's the minor. And there, we're all done. So when it just asks you to write the equation in standard form, this would be your answer. I just want you to practice finding the center, the major, and the minor, and graphing it, because that's what you're going to be doing on the test, in the quiz. Okay, example 4, we're going to write the equation, and then we'll graph it again, but we're going to start with the vertices, right? Oh, you don't have to graph this because you can graph it automatically, right? So if we're at 4, and then 4, 4, so 1, 2, 3, 4, 1, 2, 3, 4, then 4, and negative 4, 1, 2, 3, 4, that's what plus or minus 4 is. So that are your vertices, and remember your vertices are always on the major axis, right? And since we're vertical, that means it's going to be on the y squared, right? So on the y squared, we're going to have, so our major, our distance from, really I could take the major, which is going to be 8, divide that by 2, because before when we had our distance, our A or our B, we times it by 2 to get the major and minor. So here we're going to divide it by 2 to find our A or B. Doesn't really matter which one you want to label it. B, so B equals 4. And then I want B squared, because always it's the B squared or A squared going underneath these. And that's going to be 16. So underneath our Y squared is going to be 16. Now to find our minor, it has a minor of 6. Remember, it's always perpendicular to this. So we're going to be crossing right in the middle here along that horizontal x-axis there. And it's a length of 6. So from its intersection, we're going to go over 3 and 3, right? 1, 2, 3. So pretty much that's kind of how it's graphed. Just like that. So the graph is kind of done for you. But here, since it's a length of 6, here we didn't need to times it by 2 or divide it by 2 because we already have the whole length of it. So all we need to do is take that A or B, whatever letter you want to be, and then square it. Excuse me. So as you can see, right, 36 would be bigger than 16. We're saying that's on the minor, so this should never be bigger, right? The minor should not be bigger than the major. So where I went wrong on that, right, is I do need to divide it by 2. Right, that is not my A, that's the whole length. The whole length is 2 times A is 6. So I need to divide it by 2. So A is equal to 3. Now if I square it, now A squared would be smaller than 16, right? So that's a little check that you can do. So then we have underneath our x squared is going to be 9. Underneath our y squared is going to be 16, and it's always set equal to 1, right? Now, we're not centered at 0, 0, right? With an x squared and just a y squared to be centered at 0, 0. But as we can see, our major and minor axis intersect at this point, right? They perpendicular at this point, which is 1, 2, 3, 4, 4, 0. 4, 0. So that means the center would be 4, 0. So remember, it's always opposite. So with my x needs to be opposite of 4, so that'd be negative 4. And opposite of 0 is still 0, so that means I could do y minus 0 if you want to. quantity squared, or you can just leave it as y squared. Either way, it'd be fine. So there would be your equation. Alright, so here's some homework problems. Like I said, most of these I'm really just asking for you to graph. You might have to rewrite the equation. Remember, you're setting equal to 1, right? And then I asked you to graph, getting practice finding the major, the minor. But the major and minor, remember, the full distances across, right? When we're graphing, we go from the center, and we go half of the major, and then half of the minor, from left to right. It really doesn't matter which one's squared, a squared or b squared, whatever equation you want to use, just the larger denominator. You want to look at the larger denominator, square root it, and whatever that denominator, the larger denominator, is underneath, whatever that numerator is, y or x, that's the one you're going to go. Y is vertical, x is horizontal.